Okay. So Cayley-Hamilton theorem states that every every matrix satisfies its own characteristic equation. Okay, so first of all, I will revise what is a characteristic equation. So you have a 2 by 2 matrix or you have a 3 by 3 matrix. Then for a 2 by 2 matrix, say A11, A12, A21, A22. This is the matrix A. The characteristic equation for a 2 by 2 matrix will be given by lambda square minus A11 plus A12 into lambda plus determinant of A is equal to 0. If you have a 3 by 3 matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33, then the characteristic equation by shortcut, this is given by lambda cube minus S1 lambda square plus S2 lambda minus determinant of A is equal to 0, where S1 is equal to the trace of A, which is also equal to A11 plus A12, oh sorry, A22 plus A33. And S2 is equal to sum of minor of diagonal elements, and which will be equal to A11, A12, A21, A22. This is the minor of the A33 element, you can check, plus A22, A23, A32, A33, plus this is the minor of A11 element, and the last one will be A11, A13, A31, A33. Okay, this is the shortcut for 2 by 2 matrix and 3 by 3 matrix. How do we get this equation? This equation we get by solving. So if we have any matrix A, then the characteristic equation for it will be given by anyone. How will we will get the characteristic equation for any arbitrary matrix A? How will you get a characteristic equation? How do you get these equations? Anyone?
That of A minus lambda equals to 0.
A minus lambda I is equal to 0. Very good. So if you have an arbitrary matrix A, then the characteristic equation is given by A minus lambda I is equal to 0. So if you have matrix of any other order like 4, 5, 6, then we will have to solve this this determinant and get the characteristic equation. But for the examples in our syllabus, we will have either 2 by 2, 3 by 3. So what do we mean by every matrix satisfies its own characteristic equation? So by that, what I mean is, so I will take a matrix A is equal to 0, minus 1, 1, 0. So the characteristic equation for this characteristic equation is lambda square minus the trace of A, which is 0 times lambda, plus what's the determinant, plus 1 is equal to 0. So the characteristic equation for this matrix A is lambda square plus 1 is equal to 0. Okay. So by Cayley-Hamilton theorem, Cayley-Hamilton theorem, what it says, by Cayley-Hamilton theorem, the matrix A will satisfy this equation. What it will mean? A square plus 1 is equal to 0. What do we mean by 1 here? 1 is nothing but the identity matrix. So you cannot add 1, like you can see, you will have 0, minus 1, 1, 0. You make a square and you add 1. So if I start with LHS for an example, so this makes no sense. How can you add a number to a matrix? That is not possible. So what the Cayley-Hamilton theorem says, that with constant I have to give an identity also, I. So a square plus I, that will be 1, 0, 0, 1. So what do we have? So we will have minus 1, 0, 0, minus 1, plus 1, 0, 0, 1, and the answer turns out to be 0, 0, 0, 0. So on the right hand side you will get a matrix. So the right hand side here is a zero matrix or null matrix. This is the meaning of Cayley-Hamilton theorem, a very important theorem as far as inverses and higher order matrices are concerned. So the theorem says that your matrix, any matrix, will satisfy its own characteristic equation. So how do we use it? The major question is, how do we use it? So using it, uh, what we will do is we'll solve some examples and
So
we'll
can you show the
under
first page once? The first one, like just the before this one.
this one.
Yeah. Yes, sir. Yeah.
Just a
So can
minute,
you
I
show
will
the
just switch.
example you showed right now?
Just a minute.
So like after the lambda square, like how did it become 0 lambda? It should be plus lambda, right? Plus 1.
Where?
Characteristics equation is lambda square minus you wrote 0 lambda.
Zero into lambda. It's correct, na?
So like according to the equation, it's a11 plus a12, right?
What is A11 in this case?
0. And then
A22.
my so it's a11 plus a12, right? Or a22.
No, no, A22.
Oh,
That is the sum of diagonal elements. It is trace of a matrix. So trace is nothing but the sum of diagonal elements. Diagonal elements are zero here. I've written something else, or in previous lecture you have thought of something else.
I thought you wrote A1 too. So,
Oh, I'm so sorry. That is A22. That is trace.
yes.
Thank you. So let's go ahead. We will see some of the applications of this Cayley-Hamilton theorem, how it is used to find out higher order matrices, how it is used to find out inverse. So first of all, we will simply verify uh, this Cayley-Hamilton theorem for some matrix A. And the question is verify verify Cayley-Hamilton theorem for A is equal to 1, 1, 3, 1, 3, minus 3, minus 2, minus 4, minus 4. And use it to find inverse. First of all, let me just confirm. Did Sachin sir taught you how to use your calci to find out this eigenvalues?
No, sir.
No, sir.
No, sir.
So,
Okay.
No, sir.
So I will highly recommend this. Maybe our exam is online or it is offline. In both the cases, you will have to find eigenvalues. Okay, so finding out eigenvalues is very important. That can be asked for 2 marks, and for 5 marks question, eigenvector will be you will have to find out using the eigenvalue. Okay, so maximum stress is on finding out eigenvalues. Finding characteristic equation is very easy, but still there is a problem of finding out the determinant and all. So right now, if you have scientific calculator with you, please take 2 minutes and bring it. If you don't have it, I'm forwarding you this link of an application that you can simply download in next 5 minutes, and then I will tell you how to find out roots, determinants, different powers of matrix. So that will be very helpful for you later. So you have the link on your group. Please download that app immediately.
Sir, please mute.
Okay, so you have it downloaded. So what you
Yes,
do is
sir.
you open the
Yes,
app.
sir.
So I will start solving over here. So what things we need? The characteristic equation for this will be given by lambda cube minus the trace of this matrix A, which is 1 plus 3 minus 4 lambda square plus S2 times lambda minus the determinant of A is equal to 0. So I will find out S2 separately. So S2 is 1, 1, 1, 3 plus 1, 3 minus 2 minus 4 plus 3 minus 3 minus 4 minus 4. So that will be actually equal to 3 minus 1, 2 plus 2 minus 24. So which is equal to minus 20. Now for the determinant of this matrix, so what do we see over there is this. So calculate. Yeah, you can insert the equation on the screen. So what do we have is, uh, okay, first of all, and find out the determinant too. So determinant of this matrix A be equal to 1 into minus 12 minus 12 minus 24 minus 1 into minus 4 minus 6 minus 10, the last one plus 3 into minus 4 plus 6 is 2. So the answer is 8. So what do we have? Lambda cube minus 20 lambda plus 8 is equal to 0.
Sir, minus 8, right?
Sir, minus 8.
No,
The,
you
the
have
determinant
minus sign
is.
there.
So it's plus
Determinant
सर
minus.
is
डेट से
minus
माइनस
8.
एट आएगा.
Determinant is minus 8 and that minus will become plus 8.
Yes, sir.
Okay, so this determinant can be found using your scientific calculator, the one that you will have to purchase. I think FX991, uh, FX plus 991 can do it. The version of the calculator is it. So which can square the matrix, which can also, I mean, do all the operations on the matrix. It can make cube. It can find out the roots, and throughout your M1, M2, and M3, it will be very helpful to you. So I will suggest that you purchase it so that you can, use it whenever required. So in this case, using this application, I will tell you how to find out the roots. That's it. If you have that calci, we can have the lecture one. Just for introduction, how to use that calculator. Maybe after 2 to 3 days. So you take your time, bring that calci, and once you bring it, after 3 days, I'll teach you how to make square, cube of different matrices. Take the inverse of the matrices, finding out the roots, solving linear equations. Everything can be done on that calci. So it will be very helpful while you will be solving exams. Okay. So right now what we have, 1 into lambda cube plus 0 into lambda square minus 20 into lambda plus 8 equal to 0. So what you simply have to do is you just have to enter the equation. So that will be x cube. So you can see this over there. This, then you choose this button, then you have x, you shift the cursor, then you can make it cube, then minus 20 into variable x plus 8 equal to. So once you enter the equation, you press equal to, and you will get the roots of this. Okay, if you have that fx calculator, fx plus 991, so in that you will have to choose the equation. Once you give the coefficients, you can directly get the roots. So once you get that calci, let me know. After 2 to 3 days I will explain you how to find out those roots of this. Now let's get back to this. So to verify this, what we will have to do is I will have to show that the equation here is satisfied by the matrix A. So to verify A cube minus 20 into the matrix A plus 8. In this case, you cannot add this constant to the matrix, so I will multiply by I, and the right hand side I should get 0. This equation is to be verified. Okay. So now to verify A cube minus 20A plus I 8I is equal to 0 matrix. So LHS is equal to what we will have, the matrix A, which is 1 1 3 1 3 minus 3 minus 2 minus 4 minus 4 cube minus 20 times 1 1 3 1 3 minus 3 minus 2 minus 4 minus 4 plus 8 times identity 1 1 1, other value 0 0 0. So as I said, you can do the cubes on the calculator. So I will do the cube, and the cube of this I'll directly write down a matrix. If someone has scientific calculator, please let me know. I'll tell you the steps, or else I'll do it and I'll directly write down the answer. That is 12, 20, 60, 20, 52, minus 60, minus 40, minus 80, minus 88. So minus, we'll have 20, 20, 60, 20, 60, minus 60, minus 40, minus 80, minus 8, plus 8, 0, 0, 0, 8, 0, 0, 0, 8. So adding this, you should get 0, or else there is nothing to verify. Okay, simple plus and minus, you can do it. Now, the real question is finding out A inverse. So what do we have? A cube minus 20a plus 8I is equal to 0. How can we find out A inverse? Anyone?
Sir,
Multiply both sides by A
pre-multiply
inverse.
pre-multiply A inverse on both sides.
So pre-multiply A inverse on both sides. So multiplying A inverse on both sides. So what do we have? A square minus 20 times I plus 8 A inverse is equal to 0. So A inverse is equal to minus A square plus 20I divided by 8. This is the equation for A inverse. I mean, if it is an MCQ, the equation will be asked, or else in theory question you can put the values and you can find out the inverse also. Clear? So I will go to the next example now. So using Cayley Hamilton theorem for A is equal to 211,010,112. Find e raised to 8 minus 5 a raised to 7 plus 7 a raised to 6 minus 3 a raised to 5 plus a raised to 4 minus 5 e cube plus 8 a square minus 2a plus I. So we have to simplify. I mean, you have to find out this matrix using Cayley-Hamilton theorem. So what does this Cayley-Hamilton theorem, I mean, how it will work? So let's just find out the characteristic equation in this case. So characteristic equation is, so we'll have lambda cube 3 by 3 matrix minus S1 lambda square plus S2 lambda minus determinant of A is equal to 0. What is our S1? S1 is the sum of diagonal elements, which is 2 plus 1 plus 2. So that will be 5. S2 is sum of minors of diagonal element. So 2, 1, 0, 1 plus 1, 0, 1, 2 plus 2, 1, 1, 2. So first one 2 plus 2 plus 4 minus 1, which is 3. That is 7. And last one, determinant of A. Determinant of A you can find out, and that is
-3.
minus 3. Is correct. So the characteristic equation we have got is, so equation is lambda cube minus 5 lambda square plus 7 lambda plus 3 is equal to 0. So by Cayley-Hamilton theorem, what we will have is e cube by Cayley-Hamilton. What will have a cube minus 5 a square plus 7a plus 3 times I. This turns out to be 0. You have to be very careful, since we have a raised to 8, a raised to 7 and this kind of things in our equation. What we'll do is I will adjust this equation in this and I will make it 0. And how do I adjust it? So I will rub this part over here. Can you think of some way making this equation in the given equation?
Sir, we can take a की power 5 common, a raised to power 5 common in till the first four digit first four means digit of the equation.
Yes, exactly. So we'll take a raised to 5 common. So in bracket you have a raised to 8, a raised to 5 is common, so this will be a cube minus 5a square plus 7a minus 3 times identity plus in the next one the problem is this 8a square. How
Sir,
can I
write it
achieve
as
this is from
7a
8 I
square
will
plus
take
a
out
square.
1 exactly. So a I will take common first of all. So I'll have a cube minus 5a square plus 7a square
7a, sir.
minus 2i minus 2i plus I is equal to 0. Now this whole thing is 0. Whole thing is 0. So a raised to 5 into 0 plus a. In the other bracket, what we'll do is we'll make the adjustments a cube minus 5a square
Sir, again one
uh,
A is remaining there.
7a plus a I should
Yes, sir.
write down over here. Yes, yes, exactly. So plus 7a and this 2i is over there. So I will add 3i and subtract 3i. So plus
Sir, one sign problem
3i
is there.
plus a and minus 3i minus 2 minus 5i plus I is equal to 0.
Hello, sir.
Yes.
Sir, there is minus 3i in first equation, first
Well,
bracket. So,
huh.
so our equation is 7a plus means a cube minus 5a square plus 7a plus 3i equals to 0. Here in bracket it's minus 3i. So
Huh.
how it can be 0?
Is it plus 3i or minus 3i? Our characteristic equation was minus 3i. This is minus 3i. Our determinant turned
No,
out to be 3, right?
yes, yes, yes.
Yes,
Yes,
sir,
sir.
3.
Plus 3 plus
So the minus 2i term will be minus
huh.
3i plus I.
Determinant was minus 3 plus 3 sorry and minus determinant of a equal to
Yeah,
0 was
yeah,
the
yeah. Okay,
characteristic
okay.
equation. So it turned out to be minus 3i.
Yes, sir.
है ना? Yes. So now the first term is 0. A in bracket 0 plus a minus 5i plus I is equal to 0.
No, sir, sir, it would be minus 3i in the upper equation.
Yes.
So, no, no, you have written plus 3i minus 5i, right? For minus 2i. So it will be minus 3i plus
There was
I.
already minus 2i was there.
Yes, so we need
So
to
minus
we
I
need
and
to
plus
convert it
I
to minus
as
3i. You have done it to plus 3i.
yes. 7a is there plus a minus 2i is there, so I will have to subtract one more I, so it will become minus 3i, and I will have to add one I, minus I plus I. Yes, so minus 3i, this will be now a in bracket 0 plus a plus I bracket complete I. This right hand side 0 shouldn't be there. So now this will be a square plus a plus I. So now this is the simplified equation, and now if I want to find out the matrix I can put a and I can simplify it. Okay, Fine. If I go to next example, using Cayley Hamilton, using Cayley Hamilton for A is equal to 1, 4, 2, 3. Simplify the expression. A raised to 5 plus 5 a raised to 4 minus 6 e cube plus 2 a square minus 4a plus 7i. Okay, so let's just find out the characteristic equation. Characteristic equation is characteristic equation is lambda square minus the trace of this, which is 4 times lambda, and the last one will be plus determinant of it. Determinant is 3 minus 8, which is minus 5, is equal to 0. So by Cayley Hamilton, we have a square minus 4a minus 5i will be equal to 0, which will also mean that a cube is equal to 4a plus 5i. Look, simplification has two ways. The one we have already seen, I mean, you're taking something common and then adjusting the terms in the bracket and making it 0. So that method can also be used. Another method is this. You put the value of a cube over there, and then oh sorry, a square, I did a mistake once again. So 2 by 2 matrix a square minus trace of a into a. So a square will be equal to 4a plus 5i. Now we go on substituting the values. So you find the value of a square, you can find out the value of a cube. Multiplying a, what we will get is a cube is equal to 4 a square plus 5a. But we have the value of a square, and that is simply 4a plus 5i. So that will be 5i plus
21.
5a. So that is 16 plus 5, 21a plus 20i. This is the value of a cube. Similarly, I can find out the value of a raised to 4 now. So a raised to 4 will be equal to a raised to 4 is equal to a into 21a plus 20i. So that is actually 21a square plus 20a. So you can put the value of a square once again. So what do we have? 4a plus 5i plus 20a. So simplifying this, the value of e raised to 4 that we get is 21 into 4. So 104 plus 20. 104a 104a plus 105i. Then a raised to 5 will actually be equal to 104 a square plus 105 a. Once again put the value of a square. So a square is simply 4a plus 5i plus 105a. So you can put the values, you can simplify, and that will be 416 and 105, that is 100 and 121. 521a plus 520i. So we can put the values now. We can simplify this expression. So substituting the values, what we will have, 521a plus 520i plus 5 in bracket 104a plus 105i minus 6 21a plus 20i plus 2 4a plus 5i minus 4a plus 7i. So this is the way how we can simplify a very large equation to lesser powers of a using Cayley-Hamilton. So that those are all the applications of Cayley-Hamilton theorem. Uh, in the next lecture, what we will discuss is rotation, reflections, translations, and all the transformations, and which matrix does the transformation, which matrix will rotate, which matrix will take the reflection. All those things we'll discuss in the next lecture. If you have any difficulties, you can ask right now in this example.
Excuse me, sir.
Yes.
Sir, is it necessary to buy that Kelsey?
It is not necessary actually, but I am suggesting it because in engineering, anyway, you are going to need it. So you buy it today or you buy it later. But if you buy it today, you will, I mean, it will be very helpful to you to solve a lot of eigenvalues examples, and maybe in every exam, I mean, at the end, if it is online or it is midterm that you will be giving in maybe 15 to 20 days, now you will have to have this calci with you if you are not very much comfortable finding out the roots. So that's why I'm suggesting that you buy it right now.
Sir, I have a Kelsey in which all the operations are there except the matrix one. It will be fine.
Matrix one are not there.
No,
On
matrix
the
calculation is
right
not
hand
there.
side and top right hand side corner, can you tell
No,
me
sir, I
what is
have a
written?
older version of scientific calculator. That's why.
No, that won't be helpful to you much.
Sir, it will find the roots and all the things because I have done it with it. But the only
Okay,
matrix one is not there.
fine then, no problem. I mean, for time being, it is okay. If for other subjects too, it is, I mean, working for you.
Yes, sir.
Yes, Sharvil. Okay, let's stop
Sir,
here then.
sir, will a graphing calculator do?
Why do you need a graphing calculator?
No, sir. It's
And
just I have
we,
one already. That's why I was asking.
you have graphing calculator.
Yes, one of my cousins bought it because he was in IB, so now he doesn't need it, so I can get it from him.
Oh, nice. Send me the photo of which one it is. I haven't used it yet.
Yes, I will send you once I get it.
Uh-huh.
Okay.
Okay. Okay, thank you everyone.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.